All right, let's finish up these problems, numbers 16 through 18 on this review. 16 and 17, I've got some really important ideas, so let's go over those. So with this number 16, if a result is statistically significant, so remember that means that you rejected the null hypothesis. So it's to be statistically significant at the 10% level. That means, and so I'm going to make a note here, that means that your p-value is less than 10%. Okay, so that's what that tells us. Is it always significant at the 5% level? And so then that's a no. Just if you are less than 10% does not necessarily mean you are less than 5%. Just like in your class rank, if you're in the top 10%, you are not necessarily in the top 5%. Okay? So, is it always significant at the 20% level? Well, in that case, yes. If you are significant at the 10% level, if you have a p-value that is less than 10%, then you would always have a p-value that is less than 20%. Okay, so on this number 17, here we have this 32 randomly selected packages are opened, the parameter and hypothesis. So we just have this claim of 20% orange candies, but we don't know what our results are going to be. So we are going to hypothesize about the proportion of the M&Ms in the M&M packages that are orange. And so we're hypothesizing the claim of 20%, but we don't know. We were not told that we think it's higher or that we think it's lower. So therefore, I'm going to do a not equal to, a two-tailed, because I'm investigating, I don't know which direction. Then in this, look at question B. At the 2% level of significance, okay, 2% level of significance, that is your alpha. Okay, 2% level of significance is your alpha. So alpha is 0.02, and that is the rejection region. Okay, alpha, that's a 2% rejection region. And that rejection region is split between two tails. So that's why that rejection region of alpha is split between those two tails. So that puts 1% in each tail. That is then why the confidence level is a 98% confidence level. Okay, so C says if the corresponding confidence interval is this. So they got this as the interval. Would you, if you were to then run a hypothesis test, with these statements here, do you anticipate rejecting or failing to reject the null hypothesis? Well, I see that my null hypothesis is in this interval here. So I probably would. I anticipate failing to reject because 20% is plausible since it is in my interval. All right, next are phantoms. So we have our last one, which is about P equals the proportion of computer components that are defective. We think they are 7%, but suspect that they may be more defective. Does it show that there's significantly more defective parts? So let's take a look at our assumptions here. We did have stated that we had 175 randomly selected computer parts and that 175 is less than 10% of all such computer parts. So here, make sure that you are doing your sample size times your true P of 0.07. Don't put your 18 out of and the 170, and then the 175 minus 18, whatever. Don't put your sample results here because if you have true P, that's the best it can be. Only if you don't have that would you use P hat. So the approximately normal model applies. This is a one proportion Z test. So here we go. My P hat, that's my sample results. My 18 out of my 175 is 0.103. They should, all those samples should be centered at the claim of 0.07. Oh, poof. I can tell, look here. I'm going to redo this here. I made a mistake. Look here. This is wrong because look at what I did. Oh, no, I didn't. I did it right. Okay, phew. Okay, yay. So I was concerned. I thought at first I put the wrong numbers in here because I want to make sure that's the P and the 1 minus P, not P hat. So it is. I put the true P in there. Okay, good. All right, so now here is my P hat minus the true P over that standard deviation of P hats, and that's 1.74. So I'm going to norm CDF greater because I am investigating if it is higher, 0.041, which that p-value is less than alpha of 0.05. So if that p-value is low, reject HO. So I'm going to reject HO. So since the p-value is less than alpha, I reject HO. There is evidence. So see, look, if you are rejecting HO, then you have evidence of HA. So there is evidence that the proportion of computer parts that are defective is greater than 7%. Then I go double check. Let me check my question. Does this sample show that significantly more defective components are being made? And that answer is yes. So I answer that. This sample does show that significantly more defects are being made. Okay, so that was an actual AP question. Let's see what year that was. Oh, I didn't put when that was. Okay, so maybe it wasn't. But anyway, so there you go. There is your unit review for 1 proportions, confidence intervals, and hypothesis tests. All right, good luck to you tomorrow on your Unit 7A test.